Hi guys, so they want us to find the Norton's equivalent circuit for this particular network external to the resistor R. So what we need to find is that we need to find Rn and In. To find Rn, simply off all voltage sources, all independent sources. So in this case, off this, we're just going to short circuit it, which means that will just be a wire. So the circuit will now be looking like this. And at this point, it's going to be an open circuit. Now this is 5 ohms. Now these two resistors are actually in parallel. They share this node and this node together. You can redraw it like this. This is still the exact same circuit sharing two nodes. Parallel resistors share two nodes. So this is going to be 5 in parallel with 5. After that, it will not be in series with this 5, so plus 5. This is going to be equals to 2.5 plus 5, which is 7.5 ohms. Next, we need to find In. To find In, you have to short circuit the place where the load resistor is. So in this case, I actually feel most comfortable using mesh analysis. Maybe you saw another thing to use, but I know that this is one loop and this is another loop. So for the first loop, it's going to be minus 20 plus 5 I1. Then when it comes to this particular one, this particular one is in between loop current 1 and loop current 2. So it's going to be plus I1 minus I2. Because since we're dealing with loop current 1, it's going to be I1 minus I2. If we're in loop current 2, it will be I2 minus I1. All of them equals to 0. And simplify this will be 10 I1 minus 5 I2 equals to 20. So this is your first equation. And then your second equation is simply going to be 5 I2 minus I1. And then when it comes to this particular 5, because it's going like this, it's going to be plus 5 I2 equals to 0. Simplify this minus 5 I1 plus 10 I2 equals to 0. This is your equation 2. These are simultaneous equations. I'm sure we know how to solve them. If we solve it, I1 will be equals to 2.667 amps and I2 will be equals to 1.33 amps. And in this particular case, In, that is the short circuit here, I forgot to draw it, is the current going like this, and I2 is also the current going like this. They are going in the exact same direction, which means In will be equals to I2. They go in the exact same direction and in the same circuit loop, so you don't get confused, which is equals to 1.33 amps. And so now to draw the equivalent circuit, it's going to be In, which is drawn like this, in parallel with the resistance equal to, which was 7.5 ohms, then in parallel with the load resistor, which was just R. This is going to be 1.33 amps. So this is just the equivalent circuit. Thank you for listening.